So this is 8.5, the law of sines. When we finish, I'd like for you to be able to apply the law of sines. So here's what I want to make sure that you understand, or what you really need to understand to be able to get this concept. So if you know the measures of two angles and the length of a side, angle, angle, side, or angle, side, angle, or the two side lengths and the measure of a non-included obtuse angle, side, side angle, then you can find all of the other measures in that triangle. So what did all of that just mean? So it means if you have a triangle and you can use the law of sines when you have angle, angle, side. You can also use it when you have angle, side, angle. Or if you have an obtuse triangle, you can use it when you have side, side, angle. Notice that the angle for this one, let's see, or two side lengths and the measure of a non-included obtuse angle. So this is my non-included obtuse angle right here. So the law of sines, let's see, for any triangle ABC, we're going to let the lengths of the sides opposite the angles A, B, C, capital letters, be lowercase a, b, and c, respectively. Then the law of sines relates the sine of each angle to the length of the opposite side. So for the sine of A, we've got the sine of angle A divided by A is equal to the sine of angle B divided by B, which is equal to the sine of angle C divided by side C. So this is going to come into play, and you'll see more in just a few minutes. So if you're like me and you're like, so you can either skip through this part, or if you want to see why this works, we'll go through this. So if we draw an altitude from angle C through segment AB, and we're going to label it H. So we have triangle ACD and triangle BCD are both right triangles. So the sine of angle A is equal to the opposite over hypotenuse, so H over B. You see that right here. And the sine of angle B is equal to H over A, the opposite over the hypotenuse. So now what did they do to get to this step right here? That's right, they multiplied on the sine of A is equal to H over B. They multiply both sides by B. And let me do that. And then the B canceled out, leaving you with B times the sine of A is equal to H. And then over here, well, what do we multiply by? We multiplied by A. And what you do to one side, you have to do to the other. So these A's cancel out, leaving you with A times the sine of B is equal to H. Oh, I've got H and H. So I can use substitution and say, oh, B sine of A is equal to A sine of B. So on this, what did they do? Well, let's divide this side by A, and then the A cancels out. And what we do over there, we have to do over here. So let's divide this side by A. Oh, now let's divide. I've got B, so I'm going to divide by B, Oh, these b's are going to cancel out. So what I do to one side, I have to do to the other to keep my equation balanced. So now I have the sine of angle A divided by A is equal to the sine of B divided by B. So that is why we have the law of sines. Okay, so now we're going to do a problem. So we have in triangle ABC, so I'm going to draw a triangle, and it doesn't matter if it's to scale or not. So I'm just going to draw a triangle. So I've got A, B, and C. So angle A is 48 degrees. Angle B is 93 degrees. Length AC is 15. Okay, so now I'm going to write, let's see, and it wants to know what is the length of BC. So I'm just going to put X there because that's what we're looking for. So I'm going to do the sine of 93 divided by 15. And let me tell you what, let me go over here and I'm going to write I'm just going to do this and see if I have enough room. Okay, so the sine of 93 degrees divided by 15 is equal to the sine of 48 degrees divided by x. So now I'm going to solve for x. So I'm going to say, okay, I'm going to cross multiply. So I get x times the sine of 93 is equal to 15 times the sine of 48. Now I want you to notice that I put the x and I put the 15 in front of the sign of the word sine. So I do this to keep me from getting, it keeps me square. That way I don't have to worry as much about how I enter it in my calculator, and I won't think that x is part of what I'm taking the sine of. So I always put those numbers in front. It helps me, and I believe it'll help you as well. So who's in the way of x being by itself? Sine of 93. So I'm going to divide both sides by the sine of 93. So this cancels out. So I have x is equal to 15 times the sine of 48 divided by the sine of 93. So now comes the fun part. Now we get to enter it into the calculator. So I'm going to go to my handy dandy calculator. So 15 times the sine of 48, close parentheses, and I'm just going to hit equals. Then I'm going to say divided by the sine of 93. So you get 11.16. Now we're going to go back over here. Round to the nearest tenth. So the length of BC is equal to 11.2. The hardest part is getting comfortable with seeing all of these all the notation for sine. Okay, let's take a look at problem 2. So now I don't have a triangle, and that helps me. So, and actually step 1 is draw and label a diagram. So in triangle RST, RT is 11, ST is 18, and the measure of angle R is 120. So I'm going to draw a triangle that's obtuse. So this is 120, and this is R. I'll label these S and T. So RT is 11, ST is 18. Oops, put that in the wrong spot. ST is 18. So now I need to set up my equation. See, and what am I looking for? I am looking for the measure of angle S. So I am going to say the sine of 120 degrees divided by 18 is equal to the sine of S divided by 11. So the angle over the side, the angle over the side. So now I have to solve. S is my variable. So let's see. So I'm going to cross multiply. So I have 11 sine of 120 is equal to 18 times the sine of S. So this is what I'm looking for. So I'm going to divide both sides by 18. So let me write this out. So I have the sine of angle S is equal to 11 times the sine of 120 divided by 18. What am I looking for? I'm looking for an angle. So that tells you that you are going to use the sine inverse because I have my ratio. There's no variables in here. So I'm going to plug this in for the sine inverse. So let's go to the calculator. So second sine (11) times the sine of 120 close parentheses divided by 18 equals 31.95. So now I'm going to go back to my problem. Let's see, to the nearest tenth. So the sine of S, the measure of angle S is equal to 31.95. And when we round this to the nearest tenth, we get 32.0. So the measure of angle S is equal to 32. Okay, last problem. Okay, so we're going to be using the law of sines to solve this problem. Surprise, surprise. Okay, so a ship has been at sea longer than expected and only has enough fuel to safely sail another 42 miles. I'm going to highlight that. Port City Lighthouse and Covetown Lighthouse are located 40 miles apart, so they give me that information in the diagram. At sea, the captain cannot determine distances by observation. The triangle formed by the lighthouses and the ship is shown. Can the ship sail safely to either lighthouse? Okay, so what are we looking for? I'm looking for this length and this length, right? Okay, so when I look at this, I look at my angle and the opposite side. I'm looking for this distance, so that's not going to help me. I've got to have one where I know all of the information. So I have this side. Oh, but I don't have this angle. Oh, but can I find this angle? How am I going to find it? The sum of my interior angles of a triangle are 180. So I'm going to take 180 and I'm going to subtract 70 and 52. And that, my friends, gives me 58 degrees. So we have the sine of 58 degrees over 40 is equal to, well, which one of these ports do you want to find? How about we do Port City? So to find Port City, I'm going to use this angle with this side. So the sine of 52 divided by, and we don't have a value, so we're just going to call it x. Okay, so now I'm going to cross multiply. So I'm going to get x times the sine of 58 is equal to 40 times the sine of 52. Who's in my way for x being by itself? The sine of 58. Now remember, that's just a number. It's just written funny. So now we're going to divide by the sine of 58. So x is equal to 40 times the sine of 52 divided by the sine of 58. So when you plug that in your calculator, you are going to get 37.1682 and a bunch of other stuff. So now let's find, okay, so this one is 37.16. Okay, so now, oh, can we travel that far? Absolutely. So we can definitely make it to Port City. Now let's see if we can make it to Covetown. Okay, so for this one, we're going to start off like we did a while ago. We're going to start with the information that they give us. That's the information that we're going to use when we're writing our equations, because 37 or 37.1 or 37.16, that's all going to have rounding error. So we're going to use what we know is 100% accurate. There's no rounding error, and that's what, so we're going to use what they give us, which is the 58 and the 40. So we're going to say that is equal to, now which side are we looking for? We're looking for this side. Which angle is opposite of this side? This one. So we're going to say the sine of 70, and we're going to call it x again, because now we're looking for this side. I'm going to cross multiply again. So I'm going to have x sine of 58 is equal to 40 times the sine of 70. I'm going to divide by the sine of 58 to get x by itself. And what I do to one side, I have to do to the other. Even though my numbers look weird, they're still just numbers. So I want you to pause, plug this in your calculator, and see if we get the same thing. Okay, what'd you get? So I got 44.32. So that's going to be this distance right here. So will the ship make it? Can the ship make it to Covetown? Nope. So the only place that the ship can go is to Port City. And then that's all we have today.